All right, we're going to talk about our table saws. We have two table saws. Both of them are SawStops. We have one right here that is set up for ripping only. There's another one over on the other side of the shop that is set up for cutting grooves and dados. The two are virtually the same saw, but we have different setups with the blades. If you're not familiar with SawStop technology, this has what they call flesh sensing technology, where the saw knows whether it is cutting wood or it's cutting your finger. The way that it knows is there is a small electrical current running through the blade. If it contacts your finger or something conductive, it draws electricity off of there and trips a brake. Wood is not conductive, so the electricity stays on the blade and there is no drop in voltage. Okay, so the saw will work. If it does sense a drop in voltage, underneath the saw blade is a brake cartridge that looks like this. If there is a voltage drop and the brake trips, okay, this is what it would look like after it trips. You can see how it's crushed in the brake and jammed itself in the saw. What basically happens there is that it releases the spring down here and it jams that aluminum block up into the blade while it's rotating. The momentum that is interrupted causes the saw blade to then fall beneath the table, okay, making it disappear so that you can't inadvertently run into it after it's been tripped. Now, this causes an awful lot of racket. It's a lot of stress on the machine. However, these are built to take that stress. One thing I do want to mention to you, this is a fantastic safety feature. It does not preclude kickbacks or any other potential hazards on the table saw. All this does for us is ensure that you are not going to cut a finger or an arm off while you're using it. Now, great technology. Okay? It is not something that we're going to play with. We're not going to try to trip the SawStop. If we do trip a brake, the brake is $90 to replace, and the saw blade is anywhere from $100 to $150 to replace. If I find or we find out that you guys were screwing around and you tripped these on purpose, we will send home a note to mom and dad asking for the $200-some to replace both of these items. Okay? Again, fantastic technology. We like to equate it to seat belts and airbags in cars. When they first started putting on those safety devices in cars, people didn't go crash their car to see if they worked. We're going to treat this the exact same way as we use it throughout the year. Let's talk about the different parts of the table saw. The saw that we're going to look at right now is set up for ripping only. Okay? Remember, we're going to do all our cross-cutting on the chop saws or miter saws throughout the shop. Starting from the top and working our way down, the table saw has got just a few components that you need to be aware of. Obviously there's the table, and we use that table to make sure that our board stays flat and runs nice and straight through the blade. Okay, the blade on the SawStop, remember, has a slight electrical current going through it to sense your fingers versus the wood. And we'll talk about adjusting that here in a second. This piece right here is called the splitter. That is a very, very important safety feature for us. And what the splitter does is it prevents the board from pinching or closing back up on the back side of this blade. The reason we want to avoid that is because if we pinch the board back here on the back of this blade, the blade is coming up through the table. So if it squeezes here, it's going to push the board up and out of the blade, causing a kickback. So anytime you're going to operate this machine, that splitter needs to be in place. Another part we're going to use here is the fence. Okay, the fence, remember, we're ripping, so the fence is going to be used to make sure that our board is fed through the blade as straight as it possibly can. Okay, so remember, we have to have a jointed face to go on the table, and we have to have a jointed edge to go against this fence. If we can manage that, okay, we're stacking the odds in our favor to have a nice safe cut. On the fence, okay, there is a tape measure, okay, that runs out to 50-some inches long. Okay, there is a little red crosshair located on the fence that you can align with a given dimension. So that's something like 5 inches. Okay, so we can set the fence to a desired width when we're getting ready to cut our boards. Okay, but the fence is definitely a must if we are ripping. Coming down here, okay, the hand wheel in the front is to raise and lower the height of the blade. The height of the blade is directly related to the thickness of your stock. To adjust the height of the blade, you're first going to loosen the knob in the middle, and then you're going to turn the larger hand wheel, okay, counterclockwise to go down, clockwise to bring the blade up. Okay, when you have it in a position you want, you're going to snug this up. Okay, finger tight, just 2 fingers to snug that up. That's all the pressure it takes to go ahead and tighten that. In front of you, you have the on-off switch. Okay, this switch is to turn the computer on inside of the machine. This paddle is to turn the saw on itself. In order to turn it on, you'll pull out on the paddle. To turn it off, you'll push in on the paddle. All right, there's one more hand wheel that we need to look at. This hand wheel on the left side of the blade or saw is your tilt. It's going to work the same way. You're going to loosen the hand wheel in the middle or the lock in the middle. You're going to turn the hand wheel left to right to bevel or tilt the blade to a specific angle that you want. Most of the cuts that we're going to do in here are going to be at 90 degrees. Okay, so there's very, very rarely are you going to need to adjust this. But once you have it set to your angle, again, you're going to lock this center lock, 2 fingers. That's all it takes to hold that in place. We're going to talk about how to operate the machine now. Before you come over here, don't forget to visit the joiner and get a flat face and one smooth edge. Again, flat face down on the table, jointed edge against the fence. When you come over to the table saw, you're going to have to know what the width of the board is going to be when you are done cutting it. So you're going to have to consult your plans and set the saw up or the fence up based on that dimension. What I like to do first is set my blade height. So I'm going to take my board that I'm going to cut, I'm going to place it next to the blade, and I'm going to raise the blade so that I am about 1/8 of an inch to 1/4 of an inch above the surface of the board. Okay? Maybe a tooth width high. I don't want to be up like this. All right, if I'm up like this, I have an excess amount of material in contact with the blade. Okay, this could cause a lot of friction and potentially cause a kickback. So we want to have the minimum amount of blade exposed, okay, above the table, just enough to cut through your board. The next thing I'm going to do after I've set my height is I'm going to adjust my fence. Remember, the fence has got a little cursor on it. I'm going to line that cursor up with the dimension that I want to cut. It's not a bad idea to double check this with a ruler. This scale is pretty accurate, but it could be a little bit off, and it's always good to double check with an actual ruler. So to operate, I'm going to do this make-believe here so you can see, and then we'll do it for real. I'm going to get myself set up to cut this board. Anything under 6 inches wide, you're going to need to use a push stick. Anything over 6 inches wide, all right, you can go ahead and cut freehand, and I'll show you that here in a second, or without a push stick. To operate, I am going to stand to the left of the saw blade, okay, because one prime area for kickback is right in between the blade and the fence. So I'm going to start by positioning myself out of the kickback area. Okay, that way if something does go wrong with this board, it's going to go past me rather than into me. The other reason I'm going to stand over here is because the on-off switch is here. Remember, we're going to pull this paddle out to turn the machine on. We're going to push it in to turn it off. So if I'm cutting and something's going wrong, I can hit it with my knee and turn it off, and I can keep my hands on the board, okay, to keep it from bouncing around or getting thrown backwards. We never ever want to let go of the board while we're in the midst of a cut. The final reason we want to stand over here is because we need to utilize the fence. Okay? I need to make sure that this board stays tight against the fence. So if I stand here, I can push on an angle into that fence, and that board will stay tight to the fence throughout my entire cut. Okay, so I really am only pushing down into the corner of the table and the fence here. If I stand over here, I'm out of the way of the kickback area, but now I'm doing this kind of weird pull-push operation. So we want to try and minimize what we're doing in the directions that we're pushing. We're going to focus on keeping everything tight to this fence. If we're tight to the fence, we're going to feed straight through the blade, and we're going to end up with a nice clean cut and a safe cut. So the next step is to worry about hand placement. Your left hand is going to be placed on the table, your index finger and thumb on top of the board, with your middle, ring, and pinky finger pushing in to the fence. So right now, these three fingers are wedging the board to the fence. These two are pushing down. My right hand is going to go on top of the board with my thumb behind the board, and that's what's going to feed the board through the blade. So your left hand is going to stay put. Your right hand is going to push forward like so. When your left thumb can get behind that board, you're going to put your thumb behind the board, retrieve the push stick, and continue with your cut this way. Once you have the push stick on the board, your left hand can come off and out of the way, and your right hand is going to continue with the push stick to push it all the way past the blade. You're never going to leave something sit in between the fence and the blade. If you do not need to use a push stick, okay, here's what I'd like you to do. Same thing with your hands. 3 fingers pushing to the fence, 2 fingers pushing down. Right hand behind the board, right thumb behind the board. And as you feed, you're going to hook your pinky over the fence like this. What that does is it keeps this hand from wandering off of the fence. Okay, I know the fence is in a safe position, so I know if I keep my hand attached to it, I'm going to be in good shape. So I'm going to continue to push with my finger locked on the fence. Again, when the board gets past my left hand, the left hand comes off, and we continue until we're completely past the blade. So let's do that for reals. And I'm going to do that with a narrower board so you can see how this is going to work with a push stick. So again, check your height, about 1/4 of an inch to 1/8 of an inch above. Set your fence to the desired dimension. Okay, get yourself ready. Have your push stick ready. Have your board ready. Okay, I'm going to fire this up, and I'm going to try and walk through this nice and slow so you can see what my hands are doing the entire time. There's a good teaching moment. You see the push stick let go? I held the board in place, and I shut the machine off with my leg. Okay, never let go. Let's try that again. Wait till the blade stops moving before you try and retrieve any material. And when it's done moving, you can go ahead and retrieve your cut piece and remove your scrap. Another part about operating the table saw is catching the board for somebody that is actually cutting. We don't have a big outfeed table here, so in theory, as you cut, if you push the board far enough, it's going to fall onto the floor. The whole purpose of whoever's catching is to retrieve the board from the person cutting. As the board is coming across here, you are going to place your fingers on top and basically squeeze these 2 boards together so that as the person cutting pushes, both the scrap and the keep piece come off the fence together. If, for some reason, while you're catching, you lose control of this scrap piece, and only get the keep piece, leave that there. Shut the saw off, wait till it stops rotating, and then retrieve it. If you bump this, you're going to throw it into the saw blade and you're going to have it thrown back for a kickback. So let's, real quick, let's run one of these so you can see it in action. You can see by pinching these two pieces together, they all came off as one, and I was able to receive them so they didn't fall on the floor. All right, so that is how you are going to be catching while somebody else is operating. Kickback, the word of the day. The SawStop table saw is a pretty safe machine. We're not too concerned about you cutting fingers off anymore on the table saw. The really, really big danger is a kickback. And we want to make sure that we do everything in our power to prevent one. The first thing we can do is make sure that the splitter is installed on the saw blade. Okay, so if this is in place, the board can't be pinched back here. If it's pinched here, it gets pushed up and out of the saw. So making sure the splitter is in place is super important. The other thing we need to make sure we do is not cut warped stock. Okay, we have to have a flat face. If I try and run this through and this board shifts while it's in the middle of the cut, that blade is going to be bound in the cut and it's going to throw this backwards at me. Okay, so we have to make sure we have at least a flat face and a jointed edge before we come over here. The other good reason for a kickback is leaving your board between the fence and the blade. So if I'm cutting and I stop pushing my board right here, okay, I basically created a pitching machine. I have a spinning blade, a loose object, okay, and a fixed point here. If this continues to spin, it's going to grab this board and it's going to chuck this out of here like a pitching machine. So obviously, we want to make sure as we're cutting, we make sure we get that board completely past the blade. Even if we only leave it just a little bit, that's enough for that saw blade to grab a hold of this and spin it out of here and throw it out of the machine. Okay. The other reason for a kickback is you simply letting go. Okay, this goes along with the last one. If you're in the middle of the cut and something's going wrong, don't panic. Don't throw your arms in the air and run around trying to figure out what to do. Keep your hands on the board, shut the machine off with your leg, right, and then wait till it stops and retrieve the board or fix whatever is the mistake here. Okay. Same thing on scrap stock. If I have a board sitting over here and I go to retrieve it while the machine is running and I don't pick it up exactly right, if I bump it into the blade is going to grab it and throw it backwards. Right? The kickback on the table saw is no joke. Right? These boards are going to come off of here at 100 miles an hour and they will do quite a bit of damage to whatever they hit, you included. So we want to make sure that we stand out of the way. Okay, so that if anything does happen in here, it's going to go past us. Okay, we want to make sure our board goes all the way past the blade,